Hello. This is going to be part 2 of solving radical equations and checking for extraneous solutions. These problems are a little bit more advanced than the first video. So let's get right into it. All right. So I have a problem here. We have variables on both sides. Okay, I have a square root on the left-hand side. So the square root of 56 minus x is equal to x. Okay, so the technique that we're going to use here is we want to get rid of that radical. All right, so if we do that, let me get my stylus working here. There we go. Okay, so if I have the square root of 56 minus x equals x, what I want to do is I want to get rid of this radical, and I'm going to square both sides. Okay, so what you do to one side, you have to do to the other. You have to keep things balanced. But when you square a square root, it gets rid of that radical. And now I'm just left with 56 minus x. Now on the right-hand side, we did square the right-hand side. So now I have x squared. All right, so now what I'm going to do at this point is I'm going to bring all of my variables to the same side as my squared because I have a quadratic, and we know how to solve a quadratic. We're going to get it equal to 0. So I'm going to subtract the 56. I'm going to add the x, right? So I'm going to add the x, subtract the 56 over to the other side. So what that gives me is it gives me a 0 on the left-hand side, but now all the terms are on the right-hand side. So I'm going to have an x squared plus x minus 56, right? So this is now the problem that I need to solve. So we have a lot of techniques that you can use to solve a quadratic. You have quadratic formula. You could graph it and look at the x-intercepts. In this case, I'm going to factor it, and we're going to see what those zeros turn out to be. So if I do this, I need to know, because I just have x squared here, I know I'm going to have x, and x gives me x squared. What numbers multiply to a negative 56 that add up to a positive 1, that middle term, right? So that's going to be a positive 8 and a negative 7. Oops, I forgot my minus. So that gives you two solutions. And if I set those equal to 0, so I know x plus 8 has to be 0, or I know x minus 7 has to be 0. If I subtract the 8, I know x has to be a negative 8. Okay. If I add the 7, I get x to be a positive 7. Now we need to check these solutions because in these problems, we typically have some sort of extraneous solutions that we have to worry about. So I'm going to start by checking the negative 8. So if I plug that in, so if I say the square root of 56 minus 8, I'm sorry, it would be, let me erase that. It's going to be minus a negative 8, right? So I'm substituting in a negative 8 for x equals negative 8. So if I do this, I get the square root. Now 56 minus a negative. If you subtract a negative, that's really like adding. Again, you can use your calculator if you need to. That's going to give me a 64 on the inside. And if you take the square root of 64, I get 8. But if you look at my problem, the left-hand side of my equation is 8, and the right-hand side of my equation is a negative 8. Those are not the same. This is not going to work, okay? So what I know is I know negative 8 is an extraneous solution. That is not a real answer to this problem, okay? So when you substitute in, it has to work. So let's check the other value. So if I have the square root of 56, there we go, minus a positive 7. Get my pen working right here. And that would equal a positive 7, okay? So 56 minus 7 is 49, and the square root of 49 is 7. And does 7 equal 7? Yep, the left-hand side and the right-hand side of my equations are the same. So I know the only real solution to this problem is 7 because when I check it, when I plug it in, it does satisfy both the left and right-hand side of my equation. It makes them equal. Okay, so I have 3 examples, I believe, maybe 4 examples of these questions, so you can follow along. You're welcome to pause the video as we go. So this one is very similar. If you would like to pause, you're welcome to. And again, I want to try to find the value of x. So I go about it in the very same way. So I'm going to start with my problem here. Oh, I forgot my negative. Negative 10 plus 7x equals x. And I want to get rid of that radical. Okay, so when I square both sides, now I have a negative 10 plus 7x equals an x squared. All right, so now that I've gotten rid of the radicals, I just want to move all my terms to the same side as the quadratic. So I'm going to add the 10, I'm going to subtract the 7x, right? So do that over here. So let's make it look nice. I have 0 equals x squared minus 7x plus 10. So all of my terms are now over on one side of my equation. All right, so now I just need to factor. So I'm going to say 0 equals, let's factor this. So factors of 10 that add up to a negative 7, I believe are going to be x minus 5 and x minus 2. So negative 5 times negative 2 is a positive 10. And if you add them, you get that negative 7. So this is factored. And now we just want to set those equal to 0. So I'm going to make my x minus 5 equals 0 and my x minus 2 equals 0. And if you add the 5 over, we're going to get x to be 5. And if you add the 2 over, I get x to be 2. So those are my 2 preliminary solutions, right? But I still need to check them. So I'm going to take that radical. I'm going to take the square root of a negative 10 plus 7 times 5 is equal to x, which is 5, right? So I plug a 5 in, the first solution in, for all of the x values. All right, now we just need to check it to make sure that it's right. So I'm going to have a negative 10 plus 35 equals 5, which is the square root of 25 equals 5, and the square root of 25 is 5. If you notice, the left and right hand side of my equation is good. So again, that would be a good solution. Now, it is possible to have 2 solutions here, though. So I want to check the second one the same way I checked the first. So if I were to take, let's get this pen going. Sometimes my stylus gives me problems here. There we go. Okay. So I have a negative 10 plus 7 times 2 equals the x value of 2, right? So everywhere in the original problem, right, I'm plugging in an x value the same way I did before. So I'm now going to say the square root of a negative 10. Let's get this going. Let's figure out what the problem is. Okay. Negative 10 plus 14 equals 2. The square root of negative 10 plus 14 is just 4. And the square root of 4 is 2. So that checks off as well. So both of these are, in fact, solutions. So in this case, I have 2 solutions to my problem. Where in the original problem, I only had 1, right? There was 1 extraneous, that was no good. And then I had 1 real solution. Right? So the extraneous solutions we cross off, we don't count those. All right. So now the next 2 examples I have just have a little bit more work to them, ultimately kind of the same thing. So I want you to watch out for one little step here. So we're going to do this kind of the same way, right? The radical is all by itself here. So we want to get rid of it. We're going to square both sides. Okay. Now, when we square both sides, the left-hand side just becomes a 2x minus 7, while the right-hand side is an x minus 3 squared. right? So you can't just square each term. And I don't know if you remember, it's been a little while since we've done this, but if you square a binomial, okay, I'm going to get an x minus 3 and an x minus 3. It just means that I have two of the same thing multiplied by itself. And you need to distribute that out. So I have a 2x minus 7 equals, and if you distribute this out, x times x is x squared, negative 3x. Negative 3 times x is another negative 3x, and negative 3 times negative 3 is a positive 9. Be very careful with your arithmetic there. I'm going to combine like terms, right? So the right-hand side would really just be a minus 6x plus 9. And now move all your terms to the side of the quadratic, right? Get everything over to the side of that quadratic. So I'm going to subtract a 2x. I'm going to add a 7. I'm going to subtract a 2x. I'm going to add a 7. So I get 0 equals x squared minus 8x plus 16. Okay, so now I just need to figure out what the solutions are. So I'm going to try to factor this. So I need to know factors of 16 that are going to add up to a negative 8. In this case, it's going to be negative 4 and negative 4. Negative 4 times negative 4 is a positive 16, and negative 4 plus negative 4 is a negative 8. Now, they are the same factor. If you set them equal to 0, right? If I take x minus 4 set equal to 0, if you add the 4, we're just going to get x to be 4. Now, if you do the same thing with the other one, it's not going to matter. You're going to get the same answer. You don't really need to write the same answer twice. Writing it once is good enough if they turn out to be the same thing. All right, but we do need to check that answer, right? So what I'm going to do is I'm going to take that 4 and I'm going to substitute it into the original problem. So the square root of 2 times 4 minus 7 is equal to 4 minus 3, right? So everywhere I have an x value, I'm substituting in my value that I got from my solution. So 2 times 4 is 8 minus 7 equals 4 minus 3, which we all know is 1, but I'll get there. Square root of 8 minus 7 is 1 equals 1, and the square root of 1 is in fact 1. That checks off. I know that this is a solution. So my solution is 4. Now, do I really need to check the other 4? Probably not, because it's the same number. It's going to give me the same result. So my solution is 4 to this equation. Okay? So again, if you guys notice, the radical for this question is on the right-hand side. That doesn't change how I do things. It's all by itself. I have the radical no other terms on the same side of the radical, so I can go ahead and get rid of it. I can square both sides. So I'm going to go ahead and actually I'm going to change colors here to my blue. I have an x minus 5 equals the square root of 3x minus 11. I'm going to square both sides. I now have, if you square the left-hand side, it just means I'm going to get 2x minus 5s. And if you square a 3x minus 11, or the radical of 3x minus 11, I just get the inside. I get what we call the radicand, the inside of the radical. Okay, so now I want to distribute. X times x is x squared. X times a negative 5 is a negative 5x. Negative 5 times x is a negative 5x. And negative 5 times negative 5 is a positive 25. And that will equal the right-hand side of my equation of the 3x minus 11. Let's combine our like terms. And I now have a x squared minus 10x plus 25 equals at 3x minus 11. Get everything to the same side as the quadratic. Minus 3x, right? Plus 11 plus 11. So I have x squared minus 13x plus 36 is equal to 0. Right? So now it comes to the point where we need to factor. We need to solve this quadratic. So I have something that is familiar, right? So a quadratic, we all know how to solve. I need to know factors of 36 that add up to a negative 13. And that's going to be a negative 9 and a negative 4. 9 times 4 is 36. Negative 9 plus negative 4 is a negative 13. That works. Okay, so now I just want to set these equal to 0 and set this equal to 0. If I solve, I'm going to get x to be a positive 9. And if I solve this by adding 4 to the other side, I get x to be a positive 4. So I have two solutions, but we need to make sure none of them are extraneous. So I'm going to check 9 and 4. We'll start with the 9. I'm going to substitute that in. There we go. 9 minus 5 equals the square root of 3 times 9 minus 11. That doesn't look like a 9. Let's make that look a little better. So I have 9 minus 5 is 4 equals the square root. 3 times 9 is 27 minus 11. So 4 equals the square root of 27 minus 11 is 16. And the square root of 16 is 4. So that checks off. Okay, so I know 9 is a solution. Let's check to see if the other one is a solution. So I'm going to plug in a 4. So I have a 4 minus 5 equals the square root of 3 times 4 minus 11. 4 minus 5 is a negative 1. The square root 3 times 4 is 12 minus 11. So I have negative 1 equals the square root. 12 minus 11 is just 1. Or negative 1 equals the square root of 1 is just 1. Those are not the same. Okay, so that is an extraneous solution. That is no good. The only real solution we have here is 9. Again, you have to plug it in, make sure the left-hand side and the right-hand side of your equation are going to be the same. Okay, so these were 4 examples. I'm going to kind of scroll up so you can kind of see the work. So on these two, the last two, we squared both sides, and then you had to worry about a little distribution on one side of your equation. So when we square a binomial, you have to remember to distribute. On these two problems, the first two, when we squared both sides, we just had an x on one side. So when we squared it, x times x is x squared. There really wasn't a whole lot of distribution to do. So these turned out to be a little quicker. But at the end, we still had a factor. We still had to check our answers and make sure you check both because sometimes you get an extraneous solution. Okay.